So good evening, everyone. This is photoelectric effect lecture number 2, and in the last lecture we were dealing with matter waves. Yes or no? And we did this question from the last year papers, and you were able to understand the relation between lambda, de Broglie wavelength, and everything. Right? Yes or no? Now, here when we are talking about the kinetic energy of a neutron, I've come across a question, so I'll give you one more formula for this. When we talk about the wavelength of a neutron, now wavelength of a neutron, I had given you the formula. Obviously, this was the formula, the shortcut formula that came. But if I go to the long cut formula here, the formula was h by root over 2mk. Yes or no? Where k was the kinetic energy. Do we remember this formula, beta? The formula which is in green. Yes or no? Now,
Yes,
sometimes
sir.
I've seen a question where they have given temperature and they have asked what is the variation of lambda with temperature of neutron. Now what happens is this kinetic energy of the neutron depends on the temperature. So I can write this formula in this way also, bacha. H upon under root of 2m into small k into capital T. Now this small k is not the kinetic energy. This small k is the Boltzmann constant. Have you heard about Boltzmann constant? This is the Boltzmann constant, and this capital T is your absolute temperature. Do you know what is absolute temperature? Absolute temperature means temperature on the Kelvin scale. Do we understand this?
Yes, sir.
So you can just write this formula as well, because I've seen question on this both in NEET as well as in JEE. So I've given the formula for JEE students as well. So just note down this formula also, bacha. Can you do that? I'll give you 2 minutes to note it down. Anyone is there, na beta? I hope nothing is troubling you.
Niharika mic on hai.
Okay, have you noted down this formula, beta? Note them down, then I'll give you a question based on this. So that once we do a question with a formula, we will remember either the question or the formula. And whatever we remember, my job is done. Even if you remember any one of those things, the formula. And remember, did I tell you to make those short notes? That copy with a short note, did I tell you that? Yes or no? That whatever we are doing, you might be writing it it may be late at this point in time, but whatever topics are left, we can do it for that. Or you can do it for the previous topic. You would be having your notebooks where you have written all the notes, all the questions every day together, and you would be having a lot of rough copies and fair copies. So what you do is take out each and every fair copy and note down all the important formulas in one notebook. So what happens is this will help you in revising, and you will get a notebook where you have all the important formulas written in your own language, written in your own handwriting, and that will help you a lot in revising when the final day comes. Do you understand what I'm saying? Because when you try to revise it from 8 or 10, I think you would be having somewhere around 6 to 7 fair copies. If you take that 6 or 7 fair copies, it becomes a very big task. It looks like a Herculean task. Oh, I have to read so many copies. I have to find out things in those copies, and it may look very difficult. But if you can start from now, take all your previous notebooks and what you are doing in today's class. You start noting down the important points, important formulae, and keep them in one place. Do not even write any question. Do not write any question, but just write all those important formulas, important tricks that you have highlighted. Keep them with you in one copy. That would help you in revising in the last moment. Do you understand what I'm saying? So you might be, or you might be looking for revision as well. This will help you in revising, because once you're reading those notebook and writing it down, you're also revising it. Most everyone is asking me, sir, gives tip for revision. So this is my tip for revision for you. The tip for revision is start picking up your old notebooks and start making notes, very short notes in good handwriting. Make them now, and that will help you in your final D day. Do we understand this? Okay.
Yes, sir.
Having said that, let me give you a question. I hope you will try to follow it.
Sir,
Yes, beta.
so please post questions for each and every lesson in Telegram, sir.
Beta, I have sent all those MCQs. I have see, the problem with the Telegram group is once I post it once, I can't post it twice, because there is some sort of a timer put there. I don't know who has put that timer. Some sort of a timer. If I put one message, I have to wait for half an hour for the other message. I don't have that much time that I can wait half an hour, right? So that's why I have sent the entire sheets to the office and I've asked them to distribute it to you. Probably you should get it, maybe today, maybe tomorrow. I've already done that. Okay.
Okay, sir.
So, you can use those sheets to revise, but remember there are no formulas in that sheet. Formulas are already given to you by me in your notebooks. Take out your notebooks, write the important points in your own language. You can also write them on single pages and put them on the wall in front of you. Motion in 1D, Newton laws of motion, work, power, energy, this. Make them as small as possible, but put everything in that. So you can make two types of notes. One are the note in your notebook, which may be more descriptive. One are very, very small chits. And you have that, what do I call it, the thermocol thing, that to paste it in front of your study desk. I used to have it in my hostel, that big thermocol thing. And you can pin all those small formulas of small chapters there, so that whenever you said, okay, motion in 1D, done. Newton's law, done. Wave optics, done. This, done. That is how this formula will keep on coming back to you. Do you understand? So two things you need to done. Descriptive formula in one book, short formulas right in front of your study table. Do you have a study table now? Whether you are in hostel or home, you would be having a study table. Get a thermocol, big thermocol, small chits, small pins, and pin them up. Okay.
Okay, sir.
Question number 1. I'll give you 2 minutes to solve this. Remember, T, capital T is in, should be in what? Absolute scale, Kelvin scale.
Sir,
Yes, bacha.
sir, lambda by 2.
Lambda by 2 is correct. Well done. I gave the same question to JEE student. They could not do it. They got the wrong answer. Well done. I'll wait for 2 more minutes for the other students. Not to be aghast, but also to solve it. 2 more minutes. Well done. Two minutes for the others to get the answer also. Shall I do it? Now, we've already seen that this lambda is inversely proportional to the root of absolute temperature. Yes or no? So, if I call the first lambda as lambda 1 and the second lambda is lambda 2, I can write lambda 2 by lambda 1, and you must be good with this because most of the questions that you are going to have as numerical in your NEET are going to be based on this ratio concept. So lambda 2 by lambda 1 is root over T1 by T2. T1 is the temperature 27 degrees Celsius. 27 degrees Celsius is given for a reason because when you convert it into Kelvin scale, it's added with 273 and your final answer becomes 300. Do we understand this?
Yes, sir.
Similarly, 927 is also given for the same reason. 927 plus 273 becomes 1200. And you divide this, you will have 1 by 4 and root of 1 by 4 is 1 by 2. So your lambda 2 becomes lambda 1 by 2 and that is the answer that you get. We understand this, everyone?
Yes, sir.
Okay, one more question, last question of this category. Why I'm doing this? Because I just feel that you might get a question because these are the questions that are coming these days, ratios and all this. Everyone has noted this down?
Yes, sir.
I think the other class is noting it down, so I'll give them time. Shall we move ahead?
Yes, sir.
This one. Do it fast. Not take your time. Try to do it as fast as possible. The de Broglie wavelength of a vehicle, any moving thing can be associated with a matter wave. Its load is changed such that the velocity and energy both are doubled. Read the question carefully. You will not get much time to do it. Its load is changed such that the velocity and energy both are doubled. What is the new wavelength? Give you 2 minutes to do it. Anyone with an answer? Shall I help you? Or you will be able to do this? Okay, I'll give you 2 more minutes. Then I'll do it. Okay, I think I should do it. Yes?
Sir, lambda.
That is correct. The answer is lambda. Well done. How did you get it? Again, they were not able to do this. Same question I had given it to them. How? The question is how. So basically what you have to understand, this is a vehicle. This is probably a loading vehicle and its load is changed. That means the mass has been changed. Do we understand this?
Yes, sir.
Now let us find out how this lambda varies with mass and load. It is h divided by mv. Yes or no? First thing first.
Yes, sir.
From here, basically I have to get the mass thing is changed. So what I'll have to do, I don't know the change in mass, so I have to convert it into the change in velocity or the change in, so I'll eliminate mass from here. So mass will be lambda by hv from this equation. This kinetic energy is half mv square. So from here I can write this mass as 2k by v square. So basically I've eliminated mass and I've written both this in terms of the v and kinetic energy. Now if I equate both, lambda by v will be equal to 2k by v square. 1v goes away. There is one h also here. So I can now write lambda will be 2 2 by h, 2k by h into v. Yes or no?
Yes, sir.
Have I done it correctly? I hope I have not made a mistake. I've made a mistake, I think here.
The lambda equals to hv by 2.
Yes, beta. I think I have done a mistake here, right? In this one, I have done a mistake probably. Mass can be written as h by lambda v. Okay, I probably did a mistake there. Yes or no?
Yes, sir.
So I can change it now. So I'll have to change this. I'll write it again. So h by lambda v is equal to 2k by v square. So we say v getting cancelled. I can write lambda as h by 2 v by k. H by 2, as you can see, h is a constant, 2 is a constant. So I can say in this case that lambda is proportional to v by k. Okay, if you have to eliminate mass, proportional to v by k. It is directly proportional to v and inversely proportional to k. Now here velocity and kinetic energy both are doubled. Yes or no?
Yes, sir.
That means your lambda will remain same. Do we understand this?
Yes, sir.
Anyone understand this? Yes or no? Can I have reasons from everyone? Velocity is doubled. Kinetic energy is also doubled. 2 by 2 cancel out. Lambda remains Same. So that is the answer that we were looking at. I hope everyone got this answer.
Yes,
Yes or no? Okay, I'll give you 2 minutes to note this down. Please note it down. Okay.
sir.
Yes, beta.
Sir, in previous class you gave a question.
In previous class, I gave a question. Which one? Okay, we did not solve this. This question you are talking about energy of a proton and alpha particle. This is the question you are talking about.
Yes, sir.
Chalo, we will solve it again.
So 2:1.
2:1 is correct. 2:1 is correct. How did you get 2:1?
Lambda equals to h by under root 2m.
Yes. If I talk about lambda, it is h by under root of 2m into k. Kinetic energy. Kinetic energy is same. So lambda will be proportional to 1 by root over m. When we understand this, so I can write this lambda of proton divided by lambda of alpha particle will be under root of mass of alpha particle divided by the mass of proton. And I've already given you mass of alpha is 4 times mass of the proton, so it will be root over 4, so it will be 2. So lambda for proton divided by lambda for alpha particle will be 2:1 or simply 2. Do we understand this?
Yes, sir.
Well, last question remains in this category, so why should we leave it? Let us just write this, because these type of questions can come in JEE as well as NEET. So let me put this for you. A simple question. Think about it. Get me the answer. The curve drawn between velocity and frequency of a photon.
Sir,
Yes, beta.
can you please go back?
Okay, you want to note this? Note this. I'll give you 2 minutes. Note this down. Not a problem. Let me know once you are done.
Sir,
Done, beta?
sir, done. Sir, this question, sir.
Okay. Then this is the next question. I hope you can see it on your screen. Yes or no? Try
Yes,
this.
sir.
Black one.
Yes, beta?
It's black. It's that.
I can't hear you, beta.
Sir, once show previous slide, the for vehicle is lambda. That question.
Which question, beta?
The de Broglie wavelength of a vehicle is lambda. Its
Okay.
load is changing.
Okay. This question you want? Where we
Yes,
have
sir.
eliminated the mass. Yes. Tell me, what is the problem, beta? You understood this? You want to note this down? Note it down. Not a problem. Note it down. Uh,
Sir, completed, sir.
okay. Shall we move ahead now?
Yes, sir.
Okay, then we will move on to this question. Straightforward question. I have sent you that sheet for photoelectric effect. Did you get it?
No, sir.
Okay.
It did not get, sir.
Okay, I'll send you. So, can you solve this question? I have to see where the sheet is. Check it out. Can you solve this question? The curve between velocity and frequency of a photon in vacuum. What is the answer? No one knows it. Shall I do it? Okay. What is the answer? Remember, the speed of photon in vacuum is actually the speed of light. Yes or no?
Yes, sir.
Does the speed of light change in vacuum? No, sir. So the answer is A, sir. It does not depend on its frequency because it always moves with the speed of light in vacuum. Understand this?
Yes, sir.
Remember, this is a trick question, and that is why I decided to take it. Understood this, everyone?
Yes, sir.
Photon and everything we have understood. Is one question that I see here once more. So this question is related to I, so probably can also come. So we can solve this one as well. This is the question. The minimum intensity of light to be detected by human eye is 10 raised to the power minus 10 watt per meter square. The number of photons of wavelength 5.6 into 10 raised to the power minus 7 meters entering the eye with pupil area, oh god, 10 raised to the power minus 6 meters square per second for vision would be nearly, oh. Let's see if you can do this. Well, you can't do this because I have not told you how to find out this. I just got back and I did not tell you. So first I will tell you that and then we will be able to do this. Now up till now what we have done is we have found out the energy of one photon and we have found out the momentum and the mass of a photon. Now sometimes in questions like this, what we are going to encounter is the number of photons entering or passing or falling. How do you find out the number of photons? So how do you find out the number of photons? So you can move on to the section D. First was energy of photon, second was mass of photon, third was momentum of photon. Here we are talking about number of photons. How do you find out the number of photons falling on a particular body or on a particular area? If I call that number of photons as n, how many photons are falling? If I know how much light or how much energy is falling on this wall, total energy, let us say if it is U, if I divide it by the energy of one photon, I will find out the number of photons falling on the body. So it is basically total energy divided by energy of one photon. Do we understand this?
Yes, sir.
So I can write it as total energy U divided by HF, or I can write it as total energy multiplied by lambda divided by HC. I have substituted F as C by lambda. Do we understand this?
Yes, sir.
Now, sometimes instead of finding out the number of photons, as in this question, they might ask you number of photons per second. Number of photons per second falling on it. Now, how do you find out this number of photons per second? Let me call it as Sn. So what do you do is total energy divided by total time divided by the energy of one photon. That will give you the number of photons falling per second. Do we understand this?
Yes, sir.
But this total energy divided by total time is actually your power. Do you understand this power? Total energy divided by total time. So now you can write this formula as power divided by the energy of one photon. From here, you can find out the total number of photons falling per second. You can now put this formula as H into F. You can also put it as P into lambda by HC. Are you following me, everyone?
Yes, sir.
Okay. So this is number of photons per second. The relation between N and Ns is simple. N is total number of photons. Ns is number of photons per second. Has everyone noted this down? Give you 1 minute.
Yes, sir.
Note it down. Okay. The next thing that they might ask is intensity of light. So just add it EF, whatever. Intensity of light. Now, whenever we use this term intensity of light, and we have used it in the previous chapter as well. Do you remember intensity of light? I talked about intensity of light in wave optics, where you have maximum intensity, you have bright fringes, minimum intensity, dark fringes, whether it was Young's double slit experiment or whether it was diffraction, there was also always intensity, yes or no? What do you mean by intensity of anything? Intensity is a word that is associated with any wave. It may be a light wave, it may be a sound wave, it may be any form of wave. What do you mean by intensity? Anyone? Intensity is the energy falling or emitted. If it is emitting energy, then it is emitted. If the energy is falling, it is energy falling. If it is receiving energy, it is energy received. I hope you understand the meaning of all this. Na? All this. A body can absorb energy. A body can emit energy. Energy can be falling on a body. Energy can be passing through a body. Whatever. Energy falling, emitted, or received per unit area per second is known as your intensity. So I can write the formula of intensity, energy U per unit area per unit time. Do we understand this?
Yes, sir.
Now, energy per unit time is power, so I can write this as P by A. Power divided by area is intensity. Do we understand this?
Yes, sir.
Have you noted it down? I'll give you 2 minutes, note it down. Once you are done, please let me know, bacha.
Done, sir.
The other class, are we done?
Yes, sir.
Okay. Let us move ahead then. So here we are trying to understand the intensity. Now, I've seen many times in your NEET exam, you're given a point source. You are given a point source and you are asked what is the intensity at a given point. So just take it as an important note. Now, whatever I am telling you, beta, is with the experience that I've gained over this, whatever time I have been taking classes, which is a long time, which is probably more than what you are right now. I've been teaching for around 20, 21 years. So I've seen what type of questions are coming and I keep finding out what questions came this year, last year, previous year. So you have a point source and then you have another point A at a distance R from this, at a distance R from it. Now this point source is emitting energy at the rate of P. P is the power of this point source. P is the power of this point source. P is the power of this point source. Then sometimes they ask you what is the intensity received at point A at a distance of R from this power source. So remember this point source will emit radiations in all possible direction. It emits spherical wavefronts. I have already told you. So the intensity at this point will be P divided by 4 pi R square. Do we understand this? Or this intensity at this point will be proportional to 1 by R square. Do we understand this?
Yes, sir.
Please note it down. So this is the intensity received at this point. P is the power of the source. So P is the power which is emitted by this. Now sometimes they might also ask you what is the power received at point A. This is the intensity at point A. What is the power received at point A? This is the intensity at point A. What is the power that we are receiving at point A? Power received at point A. Now, power received at point A, how do you find out? It is the intensity at point A multiplied by the area. Do we understand this? I hope you can see this. Sometimes they ask how much is the power received at this point. So power received at this point is intensity multiplied by A. Intensity is power per unit area. So power is intensity multiplied by area. Do we understand this? Yes or no? So if the area of
Yes,
this
sir.
area of this part is given as S, let me call the area as S. So the power received at this point will be P divided by 4 pi r square multiplied by S. So this is the power received. P is the power which is emitted by the source. You can take the example of sun and earth. How much power are we receiving from sun? That will be power of sun multiplied by the area of earth, whatever place we are, divided by 4 pi r square, where r is the distance between earth and sun. The distance between earth and sun is very large, and therefore we don't get that much of power. But mercury is very close to it. It gets a lot of power, and that is why no one can live on mercury. Do you understand this? Yes or no?
Yes, sir.
Remember these 2 points. If they make a tough paper, then they might give you questions based on this. Okay. If you've noted it down, then let me take you to that question that we were discussing, and let me start with this one so that it would be simpler for you to solve. Shall we move on to the questions? Have you noted it down, bacha?
Yes, sir.
Here is the question coming for you guys. Find the number of photons of wavelength 540 nanometers emitted per second. So they are asking per second by an electric bulb whose power is 100 watt. The value of H has to be taken as 6 into 10 raised to power minus 4 minus 34, so that your calculations are simple. I will give you 2 minutes to solve this. This is a question from one of the previous year's papers. Are we up for it? Are we ready for it? Yes or no? No, yes.
Yes, sir.
Let's see who gets me this one.
Sir.
Yes, bacha.
Option C.
Option C is absolutely correct. Well done. That is the correct answer. How many of you got this? No one got this? Oops, that's not good. How many of you got this? Shall I do it?
Got it, sir.
Everyone got it? I still see some doubt in your minds. Shall I solve it? Oops, lots of confusion. You have to find the number of photons that are emitted. You just have to apply the formula, get the answer, and stay happy. Well, I will do that for you. How we are supposed to find? Do simple things correctly. Number of emitted per second is total power divided by what? Divided by the energy of one photon, yes or no?
Yes, sir.
Now, the frequency of photon is not given here, the wavelength of photon is given. So we apply that other formula, H into C multiplied by lambda, yes or no? Power is given as 100 volt multiplied by 540 nanometer means 10 raised to the power of -9 divided by C is given as 6 into 10 raised to the power -34. Do not worry about this, okay. The zeros are there, so worry about this. Multiplied by 3 into 10 raised to the power 8. So this will go 90 times and this will go 30 times. So basically your answer should have 3. You only have to find out the correct power. How do you find out the correct power? I hope you know this, yes or no? 30 multiplied by 100 will be 3000. So 3000 into 10 raised to the power -9 divided by 10 raised to the power of -34 into 10 raised to the power of 8. I think you will be able to do this, yes or no? If you multiply these two, it will be -34 plus 8, so it will be -26. When a -26 comes on the top, it becomes +26. +26 -9 is, I think, 15 or 14, something like that. So you will get the answer. Got this, yes or no?
Yes, sir.
Everyone got this? This is not 3000, this is 30,000. Everyone got this? You just have to do the see, and when this question comes, this was question in engineering, that's why this power is there. They will not trouble with you with the power, so they will give one answer as 3, one answer as 2, one answer as 1, one answer as 4. So basically don't have to worry about the power. They are not after your calculation, they are only after whether you know this or not. Do you understand this? As I told
Yes,
you
sir.
in the previous day, that if a question comes, you only have to, don't worry about the zeros. Most of the questions, since were the engineering exam question, that is why the zeros matter. If it would come in a NEET exam, zeros won't matter because they know that student gets confused with those zeros. They will not give that part. They'll only give the part where they'll give 1, 2, 3, 4. You have to tell me which one, 1, 2, 3, or 4. Do you understand this? Okay. Having said that, we are done with this part of your thing. We discuss about photons, we discuss about energy of the photon, we discuss our momentum, we discuss about de Broglie wavelength. Everything has been covered that was physically possible for us to cover. In the next class, we will actually begin forward with the actual topic, and the name of the actual topic is photoelectric effect. You can expect for NEET, you may not get a numerical question on this, For NEET, you will basically get a theoretical question on this. Numerical question will be from this part for NEET. Theoretical question will come from the other part, because the other part has a lot of theory, has a lot of graphs, has a lot of things that you have to remember. So for that, you may not concentrate so much on questions. I will not do so many questions numerical, because they are not likely to come. What is more likely to come is the graph and the this and that and which and what. We will concentrate more on those. So we understand this. Numericals will come from this part, not from the other part. So we'll go ahead with photoelectric in the next class, and probably in 2 classes we should be able to wind up and probably move ahead of this JEE, guys. Once we are done with photoelectric, we'll move ahead in life. So take care. If you have any doubts, you are always welcome to call me up. Take care. Have a nice day. God bless you.
Thank you, sir. Bye, sir.
Bye, bacha. Take care.